Assalamualaikum and a very good morning. I bid to our lecturers and fellow friends. So we are from Group 4 and today we would like to present our interim progress presentation. So we have chosen and decided our project title, which is Automated Seed Dispenser for Hydroponics Agriculture. Before we proceed, I would like to introduce myself and my team members first. So my name is AFINA and my team members are SYAMIM, AZRY, IMRAN, and Aiman. So the first one is about the problem statement of our project. So the first problem statement is long time consumption in the seeding process. So in most agriculture, the seeding process is usually done manually, and this is consuming. So when this happens, it reduces the productivity of plant production. And the next problem statement is the increase in labor recruitment. So when the seeding process is done manually, we would require more workforce to speed up the production. Thus, this will increase the labor cost in each production. Next is about the objective. So the objective is to create a machine that can reduce time consumption during seeding and eliminate labor-intensive tasks. So the next one is about design requirement that will be presented by Aiman.
Okay, thank you, Afina. So, today I will present the design requirement that we take from literature review that we have find during our research. So, the first one is simple construction for the machine. So, we want to reduce manufacturing costs and make it more reliable by reducing as many mechanical parts that we can reduce. So the second one is economical. For the economical point, we want to make the machine affordable in terms of features to small and medium scale farmer, maybe slightly lower from the market price. So the third point is time saving. So this is the most important point because we want to increase the overall efficiency of crop production by using automated machine and can make the time consuming reduce. So the fourth point is unmanned operation. So unmanned operation means no workers needed to do the seeding process. So it will cut the workforce cost. And the last one is substrate size compatibility. So this point, we want to make the machine that are not restricted to only one type and size of substrate. So that's all from me. I pass to the next presenter for conceptual design.
Okay, thank you, Aiman. So I will be presenting conception design. So each member have generated one design, and the members with the concept are respectively as follows at the right. Next, the first one is my design, which is concept A. So this design, it uses a drop seeder method with tube guided feature that dispense seed each row of the tray, and it has a Kinect sensor which detects and makes sure that each seed enters each slot in the plates above. And then there's a tray dispenser at the far left. Next. So the next one is IMRAN, which is concept B. So this one uses a drop seeder method also with a slot mechanism, and it uses a vibrator motor with a seed stripper to distribute the seed evenly, and it uses conveyor to transport the tray. Next. So the third one is AFINA, which is concept C. So this one, it uses a seed dropper method with tube guided feature, and it also uses a conveyor, and it dispenses the whole tray at once. Next. So the fourth one is AZRY, which is concept D. So this one uses a series of hoppers that dispense seeds into a horizontal rotating shaft at the bottom, which has holes that dispense seed at each row. And then there's a tray reloading and unloading feature at the both sides of the machine. Next. So the last one is Aiman, which is concept E. So this one, instead of using a conveyor, It uses a mobile machine which got wheels, and it uses tracks to follow, and it dispense it by vibration. So next I will be giving Imran to proceed with design selection.
Thank you, Shamim. Okay, now we have our designs, our five design, conceptual design, and now in this session we are going to develop our best design. Okay, this selection criteria is derived from the design requirement, which were mentioned by Aiman previously. Uh, and now, when we are going to select the design, we are comparing those five design with a product market reference concept. This reference uses a single row pneumatic vacuum needle dispenser system integrated with automatic conveyor, and it is priced at RM 48,000. Okay, so for now we are going to look at the concept screening. In screening, we are going to evaluate each design compared with the reference. If our design is better than the reference, we'll give it a plus, and if it's not good compared to the reference, we will give it minus or zero. Um, so as you can see at the bottom, we have total out the score, and we have we are going to proceed with design A, C, and D, and we are eliminating design B and E. Okay. So the next one, Azri will continue the presentation. Thank you.
Thank you, Imran. So I will proceed for the combination, concept combination and improvement. After we done with the concept screening, we still cannot get the best design that we want. So we combine some of our concept design to make it better. So we came out with two design, which is AD and ACD. Both has most of the feature that both share is loading and unloading automation, back conveyor system, inserting precision, and sensor usage. But the dispensing automation for both have the different type. For AD, it use D type, and the ACD use the C type. Next. Okay. Then we make it a concept scoring. So we compare with the reference for the both our combined concept. So the highest wage is time saving, which because we make it the highest rate because we based on our objective that we want to reduce the time consuming as mentioned by AFINA. So the rating is we make it from 1 to 5, which is the 3 is same as the reference, and below 3 for the worst, and the worse than reference, and the highest than 3 is for the best, better from the reference. So based on our concept scoring, uh, ACD has the highest total score, so we choose it and we will be develop it to make it better. So next, based on our Gantt chart, right now we are at material selection and costing. So inshallah on Tuesday, on this Thursday, we continue to make it design optimization and calculation. So this we will send this video for the progress presentation. So that's all from us. Thank you.